So, Dr. Happer, you're directly from Princeton University here in Vienna. And can you tell us a little bit about your research, what you found out, and what your main findings that you had in your career, in your life about climate and energy, what you've been working on?
Well, thank you, Isabel. I am Will Happer. I'm a retired professor of physics at Princeton University. And I was originally trained as a nuclear physicist, but I know a lot about atomic physics and atmospheric physics and related fields. And I got into the climate issue completely by accident during the Strategic Defense Initiative, Star Wars, back in the United States. I was doing summer work for a Department of Defense in a little group called Jason. It was a mostly classified work. And in the summer of 1982, the Star Wars work had just begun, and they were looking for every possible way to defend the United States from missile attacks from Russia, because Mr. Reagan wanted to be able to defend us rather than retaliate with nuclear weapons. Better to defend than to commit mutual suicide. So the scientific and engineering community in the United States was charged with thinking of any possible way to defend against missile attacks on the United States. And you can think of using rockets, anti-ballistic missile rockets, but there are other things you can think of, and one was high-power lasers. At that time, we knew how to make very powerful lasers with megawatts of energy. And if you put a megawatt on an incoming missile, that would destroy it, would destroy the warhead. But the problem is you have to propagate the light through the atmosphere to the incoming missile that's coming towards you. And by the time this enormously powerful beam of light reaches the missile, it breaks up into hundreds of little subbeams, each one of which is too weak to cause any damage. And so it turns what would have been a rifle shot into a shotgun with birdshot, and it doesn't hurt the target. And the reason for that was very well understood in astronomy. I knew enough astronomy to know why that was. It's because the air between you and the target, even on a beautiful, clear day, has little patches of warm air and cool air. And so the wave of light going toward the missile, instead of remaining flat or properly curved, gets wrinkled. And so the wrinkles, when it finally comes to a focus, get transformed into these little filaments I mentioned. And the same problem occurs when you're looking at stars. When you have a big telescope looking at stars and you focus the star onto a photographic plate or CCD today, instead of seeing one star, you see hundreds of stars and you're not sure which star is which. And if there are two or three together, then this speckle pattern gets all confused. So astronomers were familiar with this and they knew how to fix the problem. And the trick was that you build what's called a rubber mirror. So the wrinkled beam of light coming from the star hits a mirror which you've intentionally distorted. That's why they call it rubber. So it's not a perfect parabola or whatever it's supposed to be, but it's distorted in the anti-direction of the wrinkled light. So you have to be able to measure the light to know which way to distort it. But you can do that. And then when the distorted beam bounces once, it gets corrected because all of the wrinkles are taken out, and it focuses and you get a nice point image of the star and you can do your research project. And so astronomers knew how to do that with a few very bright stars in the sky. There are half a dozen in the northern hemisphere, about the same in the south. But if the Russians were to attack us in the direction of one of those bright stars, we could defend ourselves. But as I said, there are only 4 or 5. There's one here, one there. And, they can come from any direction. So during this highly classified meeting, which involved a few scientists like myself and involved Air Force officers and government scientists, I said, well, I know how you could solve that, because you can make an artificial star with the aid of the layer of sodium atoms that's overhead. So 100 kilometers above our heads, 90 maybe, all around the world, there's a layer of sodium atoms. And the reason they're there is because as the Earth orbits the sun, it is plowing through dusty, planetary space, and the dust particles burn up at 100 kilometers, and they're full of sodium. And the sodium atoms sit there for, weeks, and there are enough of them that you can scatter light off them very easily. And so if you point the right kind of laser up at the upper atmosphere, you can make a bright star anywhere you like by reflecting on sodium atoms. So that eventually became what's called the sodium guide star today. So if you go to any big observatory now, Chile or, Hawaii, at night you'll see these yellow beams going up to the sky. And so that's my invention. That's the sodium guide star. And it allows astronomers to see some things just as well from the ground as you would normally have to go to space to see too, because you take out the distortions of the atmosphere. So I tell that just to explain how I happened to come into the climate business, because as a result of this, which to everyone's surprise worked and was very highly classified for over 10 years, I got to be known to a few people in Washington who were very influential and were able to hire whomever they wanted, to help. And so in 1990, they called me to Washington to head up the Office of Energy Research at Department of Energy, because a few people there knew that I'd solved this problem and that maybe I could solve some more for them. So I went, and I had a huge array of research I was supporting. There was high energy physics, there was plasma physics, geophysics. We were even supporting the Human Genome Project, but also climate. And I was very surprised as I learned about all of these areas that climate was not like normal research. It wasn't like geophysics. It wasn't like, the human genome or the other things. It was very political even then. And they were much more interested in what was the required political answer than what was the real answer, without any consideration. What's nature really doing? And they really didn't want to know so much what nature was doing. They wanted to know, what answer do we need and how do we get that answer? So I knew this was a problem, and but I was very busy. I had many other things in my portfolio, and Mr. Gore was one of the protectors of the climate scientists then, and he knew that I was skeptical and was giving his scientists a hard time, which I gave to all the scientists a hard time. I wanted to get their money's worth out of the taxpayer's dollar. But he eventually became vice president, and so, of course, he immediately fired me, which I was happy to be fired. I wanted to go back to doing research myself. I was tired of being a bureaucrat. So he did me a favor. I've always been grateful to him for doing that. Maybe he doesn't think it that way, but I'm very fond of him for bailing me out of Washington. But anyway, we were still working back in my home institution in Princeton on other things that I had developed, and they had become very promising, and we did a startup company, and we did a lot of very interesting work, and eventually sold the company and made some money. And so after 10 years, I began to have a little more time. I'd finished the things I'd wanted to do, and I was approaching retirement. So I began to write articles about problems with the narrative on climate, that there was a climate emergency. I knew perfectly well there wasn't one because I had funded the work, so I knew more than most people. And as years went by, I continued to do more and more of it. And so I'm continuing to do it today. That's why I'm in Vienna. I'm trying to help in this conference and to try to tell the truth about this. I mean, climate is important, and it's a real disgrace that we've squandered so much money on sort of ideological goals for climate science when we should be working on real climate science and getting the right answer. I mean, it's important, you know. You look at human history; it's always been an important role, but we've probably set it back by 50 years, is my guess, by squandering so much money on, you know, stupid computer models and you know, other things, you know, fudging data instead of really good instruments for measurements. You really unbiased research, you know, try out this idea, try out that idea, and see why it's true or what maybe it's false. But anyway, let the cards fall where they may.
You talked about like the research that you did back in the 80s.
Yeah.
For the people who watch our video, and also maybe for me, for someone who is not into science.
Yeah.
Why are you creating artificial stars? So what's the purpose of it?
Well, the purpose is, you know, if you go out at night with your own eyes, you see stars twinkle.
Yes.
And you're seeing part of this effect that I described. But in order to get the speckles I mentioned, in order to see 2 or 3 stars or 100 stars, your eyes would have to be as big as this, you know, telescope size. So when they get that big, these distorting effects of the warm and cool air in the atmosphere make it very hard to get a good picture of a star. Instead of seeing 1 star, you see 100 stars. And it's called a speckle pattern. So you don't see a point, you see lots of speckles. And for the astronomers, the whole point is to get better pictures of stars, understand them better. For example, one place that the sodium guide star has been very important was in the discovery of the black hole at the center of our galaxy, because you know, it's very dusty and dense there, and you have to look with ground-based infrared telescopes, and without the adaptive optics, the sodium guide stars, you can't distinguish the very nearby stars of the black hole. They all have speckle patterns, so if you could not get rid of the speckle pattern, you can't tell which is which. And it's very dramatic now when you look at these nearby stars. You can see them orbiting this black hole. It's amazing how fast they go. In 2 or 3 years, you know, they go all the way around the black hole. And you can see that very clearly with this instrument, you know, infrared astronomy, ground-based astronomy, plus the sodium guide star. Yeah.
So that's what you came up with.
Yeah.
So basically detecting the stars around the black hole.
I didn't do that work, but I invented the guide star that was used by them.
Yes.
Yeah. So I wish I could claim credit for that, but I can't.
Oh, that's
yeah,
fine.
they're real heroes for doing that. Yeah.
Okay. And then you told us that like with the time you get into this climate science a little bit more. How was that going? Like, what was the start of it? Were you interested in that, and why did you put up reading about what especially what you know?
When I was at the Department of Energy, it was already politicized, but it wasn't too bad. It was a little bit like, you know, astrology. You know, I hope I don't offend anyone, but you know, if you buy a horoscope, you're wasting your money, and it won't do you any good. But it doesn't harm anyone else, so I don't have any problem. If you want to spend your money that way, that's okay. And so I thought of the climate business as a little bit like that. It's not very expensive, but then the costs kept going up and up and up, and we were spending more and more money. And then it went from sort of scientific narrative to economic issues. You know, you're not going to be able to buy a gasoline car. You're going to have to buy an electric car, and you're not going to be able to use a gas stove in your home. And so then it began to be very serious, you know, so it was no longer sort of a laughing matter like a horoscope. So I think when I began to realize that this was going to happen, that was when I began to react more vigorously and take a more active role, speak out more.
Okay, so this is basically what you're doing. You're speaking out, you're going to conferences, you speak with your experiences about what is happening, and you're
trying to educate, especially young people. You know, while I wasn't paying attention, we have been teaching poor children, that there's this climate emergency, and some of them take it very seriously. They trust in adults, they trust in what appear to be dignified, trustable people, and yet they're being lied to. In fact, some of the people lying to them are quite sincere. They themselves have been misinformed. So I feel kind of sorry for the people who've been brainwashed, and they're not bad people, but they've been very badly misinformed. And so I'm hoping to get through to them, and especially to younger people, keep them from being, led down this ruinous path. There's this great book, maybe you've read it. It's called Extraordinary Popular Delusions and the Madness of Crowds, but it was written a long time ago, 1840 or something, and it describes all of the incidents like this in the past, the Children's Crusade, the witch burnings, the tulip mania in Holland, just one mass hysteria over something completely false after another. And this is very much like that. If there's a new edition of the book in 50 years, it would include climate at that point. A popular mass delusion and a madness of crowds. Yeah.
Okay, so what would you tell people to believe in this climate issue? So are there certain things that you say, okay, this is true, and we have to do something about it? What would it be?
Well, they should first, they should try and learn a little for themselves. So the first thing they should understand is carbon dioxide, which is the villain in all of this, is actually very beneficial to life on Earth. You and I breathe out about a kilogram of CO2 per day, and there are 8 billion people in the world, so there are 8 billion kilograms just from people breathing. And you multiply that by 365 days in the year, and a fair fraction of the carbon dioxide being emitted is just from people being alive. And so the real fanatics say, well, the problem isn't automobiles, it's people. We can't afford to have 8 billion people. We have to get less than 1 billion. And well, that begins to get kind of scary. That means that 7 out of 8 of us have to disappear from the face of the earth. Who's going to make that decision, and how will it happen? So that's really dangerous fanaticism. And it's based on a lie, because the fact that we breathe CO2 is that life is based on carbon dioxide. I'm looking at the green plants here. They're all made of carbon dioxide. They're sitting here in the sunshine, sucking in CO2. And if we were to take a CO2 meter there, we would find that CO2 levels in the plants are about a half what they are in the air above us, because the sunshine has let them suck it out of the air. And so all around the world, if you look at vegetation, it's growing better today than it did 50 years ago because of more CO2 in the atmosphere. Well, then you can say, well, okay, maybe that's true. Plants grow better, and which is absolutely true, but it's going to cause dangerous warming. And well, again, I would ask your listeners to look into this more carefully. If you really look into what CO2 can do, it's a very inefficient warming agent. It's what they call saturated, that's sort of the jargon term, but it means that we've long since passed the point of diminishing returns of adding CO2 in terms of warming the planet. So every additional ton of CO2 that goes into the atmosphere causes less warming than the previous ton. So the response curve, which was initially steep versus time, is now getting very, very flat. And so you have to double or quadruple CO2 to make very much difference. And, it would take a century or more to double CO2, and quadruple it, many, many centuries. So there's no emergency whatever. All of the effects that we can see from CO2 today are all good. There's none of them bad.
What about methane? Methane?
Well, methane is also what they call a greenhouse gas. Let me explain what a greenhouse gas is. If you look up at the sky, you see the white clouds and there's nothing in the way, although there's lots of carbon dioxide and water vapor between us. They don't hinder the white light from the clouds or the blue light from the sky. So greenhouse gases are transparent to sunlight, to the visible light that we're seeing here today. But, the Earth is at the same time radiating infrared light. So, I can feel through my feet that it's a little warm here because the sun was shining on these plates not long ago. And that's radiating up to space. And greenhouse gases do intercept that. So they make it harder for radiation from the ground to get back to outer space. And eventually, whatever the sun puts down here has to go back to outer space as infrared radiation. And it's true that methane and carbon dioxide and nitrous oxide, they all somewhat hinder that, but they don't hinder it very much. Now, methane is interesting because there's much less methane in the air than there is carbon dioxide. You measure carbon dioxide in hundreds of parts per million, but you measure methane in hundreds of parts per billion, 1,000 times less. And so it's true that if you add one methane molecule, it's about 30 times more effective in warming than one CO2, right? So that sounds like methane is very dangerous. But what they don't tell you usually is that, well, yes, that's true, but the rate of increase of CO2 is 300 times greater than that of methane. So the actual effect of methane, you take 30 and divide by 300, is 1/10 that of CO2. So methane is not completely trivial, but it's a tenth of CO2. So the major greenhouse gas is water vapor, number one, CO2, number two, and then methane, nitrous oxide, freons, they're almost irrelevant. They're so small. So anyway, the point is that greenhouse gases like methane and carbon dioxide, water vapor, and they're very heavily saturated, so you can change them by large amounts, and it doesn't matter. It's a little bit like, if you know some chemistry, it's like a buffered solution. If you add acid to a buffered solution, the pH doesn't change very much. And so it's a little bit like that. Yeah.
You seem to be a man who knows a lot and who's getting into a lot of topics. Do you have a guess why this is done politically? Why this has been told us for so many years and decades now?
Yeah. Well, I think many politicians were sincere, and they this sounded like a good thing to do. Everyone wants to have a meaningful life. And so what can be more meaningful than saving the planet? Even if the planet doesn't need saving, if you can save the planet, you've had a life that's worth living. And so the typical politician hated mathematics and gymnasium and, did political science or history and really doesn't understand science, doesn't understand mathematics, hates them. But they're useful in this case, that it gives them a cause to fight against. And so it's very useful for politicians, and that's, and politicians need an enemy. And it's much better to have an enemy that's just a gas than some other person, or a race. So in that sense, we should be glad that that's the enemy they picked, inorganic molecule. And then but things have gotten more complicated now because lots of money is being spent. So there are lots of people who are profiting enormously from the so-called climate emergency, the sustainability energy people, and the wind turbine makers and the solar panel makers and the electric car makers. And so all of them are getting big subsidies from you and me, from taxpayers, to produce products that are really not very good. I've driven electric cars, and they're very nice, except that you have to recharge them. They're very hard to recharge, and you can't turn on the heater in the winter. They don't have enough power to both drive you and to heat you, or not for very long at least. And so we have all this inferior technology pushed on the average person that really shouldn't be pushed. There's no reason to do that. And so it's forcing technological change that really shouldn't happen, because it will lower everyone's standard of living. It will lower their freedoms. So there's nothing good about it. And it also, it's corrupting in the sense that it's sort of maintaining a lie, and so there's just nothing good about it. And I think sooner or later it will collapse. And so what I'm trying to do is to make it collapse sooner rather than later, because the longer it goes, the more damage it is done. Yeah.
What would you recommend to people, or what would you like people to do, like the normal population in Europe and also in the US?
Well, first of all, they should get themselves educated, because they have been brainwashed. I come to an airport and I see nothing but propaganda in Europe. I mean, we're beginning to get that in the United States too, but for years it's been much worse in Europe. And, very plausible looking advertisements with green this and that, and, environment friendly this and that, but it's all nonsense. It's not true. And so, but that's all so many people in Europe have seen since childhood. And so somehow they have to have remedial education to find out what the real facts are. So first thing is to learn that. Then the second thing is to, Europe, after all, is a group of democratic countries, and so they should elect representatives who will show some common sense instead of hysteria. And there are lots of people like that, and all they need is a little encouragement, but they need people to vote for them. So voters should pay attention. It matters how you vote. And, these are not very deep suggestions, but they would work if people would do them. Yeah.
But first of all, you need the voters, like the people, to be educated.
You need to get educated.
To look into the right sources, not just the sources that are told by the media probably, but just to look into other sources as well, scientific sources.
Right,
but this is quite difficult, because most of the scientific papers are not written in a language that a lot of people understand, or it takes a lot of effort.
That's part of the problem, yeah. Yeah, most people, maybe Europe is better, but in United States, people are not very good at mathematics. They don't like it. And these are quantitative things. It's true that greenhouse gases warm. So the issue is how much, and that's numbers. Yeah. And so if you understand that the numbers are so small that it doesn't matter, that's fine. But most people have trouble with that. They have difficulty understanding that 100 years from now, the warming from CO2 is unlikely to be more than a degree, of centigrade, which you can't even feel really, and would probably be beneficial. It slightly increased growing seasons, and most of the warming is actually not during the day. Like now, CO2 hardly makes a difference. It's at night. So at the nighttime, low temperatures have been going up, but if you look at daytime temperatures, they hardly change. And that's what you expect from greenhouse gases. They're warming things, yeah.
So the nights are not as cold then?
The night is not as cold, but the days are about the same.
Okay.
And it's a much bigger effect near the North and South Pole than it is in temperate latitudes or near the equator. The equator won't really warm at all. So it is something that's characteristic of high latitudes, polar latitudes. Okay. Yeah.
Very interesting. Thank you very much for the interview, and thank you for coming to Vienna.
Thank you, Isabel.
Idealism prevails. Make the world a better place.